Everybody, today we're trying to find the smallest positive integer such that this quotient that depends on a natural number or an integer is an integer itself. Okay, now note that it's very easy to find a negative integer that gets the job done. If you put a -7 right here, this is just 1, right? So you would get 7 squared since you got an even exponent. I mean 7 to the 4th since 4 is an even exponent. -7 plus 17 over 1. And you can see clearly I picked that because -7 plus 8 is just equal to 1. So indeed, whatever this is in the numerator, it's an integer, and it's divided by 1, so it is an integer. But notice we're looking for the smallest positive integer. All right? So it turns out doing a synthetic division is the way to get this done, synthetic or a long division. I'll show you the details of the synthetic division after this relatively brief video. But when you do this division, you end up with n cubed minus 8n squared plus 64n minus 511 as your quotient, and then 41 over 5 as your remainder, okay? Now notice that this quotient is guaranteed to be an integer, right? I mean, this is an integer just by closure, right? So really the only thing we're interested in is the remainder over the divisor. So this is guaranteed to be an integer for all choices of n. Now let's take a look at the part where we have to actually do some thinking here. 4105 is close to being prime. In fact, 41 over 5 is the same thing as 5 times 821. That's an easy mental calculation. 5 times 821 is 4,105. So we got 821 right there. Now, y'all, it turns out 821 is prime. It's the square root. You guys familiar with the primality testing? All you have to do is check all the prime divisors less than 821, the square root of 821. And I think this is approximately 29. It's maybe a little bit less. So really, there's not that many prime numbers to check. And there are no prime divisors of 821 between 2 and 29. So that's why 821 is prime. And that does take a little bit of checking if you're going to do it by hand, okay? So this gives us a very steady path because we know that the divisors themselves, and I'll just write them down. We can see that n plus 8 has to equal to the divisors of 4105. But the prime factorization gives us an easy that's very simple. We know that 1's a divisor of anything. Plus or minus 1 is a divisor of any integer. And I'll just write the plus or minus one time. We have plus or minus 1, plus or minus 5, and plus or minus 821. And finally, the number itself, 5 times 81 is 4105. So these are the 8 divisors. Now, I'm sure you've noticed already that we don't have to worry about the negative divisors here because n plus 8 equals to a negative is guaranteed to be a negative number, right? N plus 8 equals to a negative number means n has to be negative also. That's very clear. So let's take a look at the positive, what happens with the positives. Remember, we are trying to find the smallest positive integer n. So let's take a look at what's going on here. N plus 8 equals to 1. That would imply that we've already seen that that's n equals -7, right? That was our trivial case at the beginning, right? So n is equal to -7. We've already accounted for that just by observing earlier. How about n plus 8 is equal to 5? And I guess you see what I'm doing here. I'm literally forcing this divisor to be equal to the divisors of the quotient. All right, and that's the only way that this part could ever resolve to an integer, right? So this would imply that n is equal to -3, so we're not interested in that, right? Now let's take a look at n plus 8 is equal to what? 821. Okay, this is going to imply what? If you subtract 8 from that, you get n is equal to 813. All right. So we do have a positive integer. It doesn't look like a small positive integer, but it is a positive integer nonetheless. Now the last one we have to check, and you guys can see the writing on the wall, n+8 equals to 4105 itself, which a number is always a divisor of itself, right? So you have 4105, and it's clearly a larger number than 813, right? N's going to be equal to what? Would that be 4097, folks? 4097? Now, these are the only positive integers that result in that original quotient being, this quotient right here, this is the original problem, right? So that is 4097. These are the only positive integers, but this is the smallest one, and this is the answer to the question. 813 is not a small number, but it's the smallest of the positive numbers that we have. And y'all, again, you can see what would happen if we had said n+1 is equal to -1. You would get n is equal to -9. If we'd have said n+8 is equal to -5, you would get n is equal to -13. So all of the negative divisors were not relevant here. This is the solution to the problem. Now, I told you I would show you how the long division occurred. You can see right down here the result of this synthetic division, excuse me. The 1 is a coefficient of n to the 4th, and 1 is coefficient of n, right? But you have a cubic term. You have an n cubed term that would have a coefficient of 0, right? And then you have an n squared term with a coefficient of 0. Now, you got to see how the synthetic division goes. You bring this 1 down, and all you have to do is multiply. -8 times 1 gives you -8. Now, you do an add. 0 plus -8 is -8. -8 times 8 is 64. Add again. 8 times -8 times 64 is -512. Add, you get -511. -8 times -511 is 4088. Add that to 17, you get 4105. Okay, and this is our big number that we had to check. So that's how you do synthetic division, folks. It's easier than long division. Notice it was all broken down into just multiplication and addition. No quote exponentiation took place. All right, so that does it. Find the smallest positive integer. What do we get? We got 813. So let me write that down. N equals 813. N is equal to 813. Tough number to check, but you can check it out if you want to, folks. 813 to the 4th power is not anything I would enjoy doing. But rest assured that when you put 813 here, here, and here, you do get an integer. Thank you for viewing.